Hello and welcome. In this video, we're going to learn about conditional statements. Our goals are that we can identify parts of conditional statements, write statements, and understand their relationships, that we can determine if a conditional statement is true or false, and that we can write and verify bi-conditional statements. So let's go ahead and jump in. So there's a lot of vocabulary that comes in this section, and I don't want you to worry. We're going to go through it slowly, and then we're going to tie it to specific examples to make sure we truly understand it. So a conditional statement, the big topic in this whole lesson, is a logical statement that has a hypothesis and has a conclusion. So for example, if Miss Baker has to watch the movie Cars, that would be our hypothesis. Then she will be angry. Miss Baker does not like the movie Cars. So a conditional statement is a logical statement that has a hypothesis and a conclusion. If it's written in this form where you see the if-then, it's called an if-then statement. The hypothesis would be the if part, and the conclusion would be the then part. Notationally, you will see that written as P, and then this arrow symbol, and then Q. That means if P, then Q. Or you could read that as P implies Q. The next word we're going to talk about is negation. The negation is just the negative of a statement, or the opposite of an original statement. The symbol that we use is this little squiggle, so you would see it written like this, which would be read out loud as not P. The converse simply switches the hypothesis and the conclusion. So if we look at the statement above talking about Miss Baker and the movie Cars, the converse of that statement would be, if Miss Baker is angry, then she has to watch the movie Cars. That doesn't necessarily make sense. That's going to depend on the statement, but the idea simply is that we are switching our hypothesis and our conclusion. That's the converse. The inverse negates the hypothesis and conclusion. So it changes everything, hypothesis and conclusion, and so that would be that little negation symbol in front. The contra-positive, I'm going to use green again because it goes with the converse. It takes the converse and it negates it. So the opposite of the first statement, opposite of the second statement. Two statements are equivalent when both statements are true or both statements are false, and we just use an equal sign for that. And then lastly, a bi-conditional statement is something that we can use the verbiage if and only if, and that means it's true and its converse is true. So we would use a double-sided arrow because both of those things imply each other. Again, right now we're just laying the foundation. We're going to look at examples, and it's really going to help that vocabulary make more sense. So let's get to those examples. Okay, circle the hypothesis, underline the conclusion, then rewrite as a conditional statement in the if-then form. So none of these are currently written that way. We're going to write them that way, and we're going to identify the hypothesis and conclusion. So we're going to circle the hypothesis. Number one says all birds have feathers. So we're going to circle the hypothesis, and we're going to underline the conclusion, has feathers. I actually think this is easier if we think about it as an if-then statement. So we could say if an animal is a bird, then it has feathers. So it's much easier to identify the hypothesis and the conclusion if we're reading it in the if-then form. You are in Texas if you are in Houston. So the hypothesis is you're in Houston, and the conclusion is because you're in Houston, you must be in Texas. So we would say, if you are in Houston, then you are in Texas. Okay, I'm going to have you go ahead and pause the video and try 3 and 4 on your own. Circle the hypothesis, underline the conclusion, and then write it as an if-then statement. Then unpause the video and see how you did. Okay, for number 3, we're talking about if an angle is 30 degrees, then it is acute. And for number 4, if 2x plus 7 equals 1, then x is equal to -3. Now that we've talked about hypothesis, conclusion, and if-then statements, we're going to move on to negation. So the negation is just the opposite of what is currently written. So number 5 says the ball is red. The negation of that would be the ball is not red. Number 6 says the cat is not black. So the negation would say that the cat is black. So go ahead and pause the video and get all 3 of these down. Try number 7 on your own and then unpause the video to see how you did. So I've now added that third one. Cars 2 is not a good movie. Now that we have some of the basic vocabulary down, we're going to work on the notation and the other types of statements that we learned in our vocabulary section. Okay, for this set of examples, we are going to define our hypothesis, P, to be that you are a guitar player, and our conclusion, Q, to be that you are a musician. And for each of these examples, we're going to follow the notation. We're also going to identify from the table of vocabulary what we're being asked to do. So number 8 is actually just asking us to write the if-then statement. So this notation just means if P, then Q. So we're just going to write the if-then statement. So in words, that would mean if you are a guitar player, then you are a musician. If you are a guitar player, then you are a musician. So we're going to write each statement, and then we're going to determine if each statement is true or false. If you play guitar, then you are a musician. That is a true statement. So this notation just means write the if-then, if P, then Q. As opposed to number 9, which is actually asking us to write if Q, then P, and that is the converse. So instead of writing the original statement, the if-then statement, we're going to write the converse. The converse means we're simply switching our Q and our P. So we're going to write if you are a musician, then you are a guitar player. There we have that statement. And that statement is not necessarily true. It's not true all the time. If you are a musician, you could play a lot of different instruments and you don't have to play the guitar. So the converse switches the hypothesis and conclusion. And in this case, this converse is false. If we look at number 10, remember that little squiggle means not. So this is not P and then not Q. So we're going to look at number 8, but we're going to change everything. We're going to negate everything. And when we negate everything, that's called the inverse. So what we're finding on number 10 is the inverse. If not P, then not Q. So if, looking at number 8 as our guide, if you are not a guitar player, then you are not a musician. So we're going to write that statement here. Go ahead and pause the video and write that statement. So there we have our inverse, where we negate the hypothesis and the conclusion. And this is also false. Just because you don't play guitar doesn't mean you aren't a musician. And then lastly, number 11 says not Q means not P. So this is the opposite of the converse, and that's called the contra-positive. When we negate the converse, it's called the contra-positive. I know, lots of vocabulary here. But all we're really going to do is we're going to take our number 9 answer and we're going to put not. If you are not a musician, then you are not a guitar player. So go ahead and pause the video and answer that one. And this statement is true. If you aren't a musician, then you don't know how to play guitar. So that would be a true statement. So we're really focusing on that notation. The little squiggle means no. The P, then Q, the arrow is telling us which indicates which. So which is if and which is then. All right, before we wrap up this video, we're going to look at one last example, and it's going to tie a bunch of those concepts together while also adding the bi-conditional. And remember, the bi-conditional means both the way that you read it and if you read it in the converse of it, both of those statements are true. So go ahead and pause the video and see how far you can get on 12, 13, and 14, and then unpause the video and see how you did. All right, hopefully you've had time to work through these 3 problems. The statement says 2 lines are perpendicular if they intersect to form a right angle. So 2 perpendicular lines do intersect to form a right angle. So this statement is true. The converse of this statement, so this says if they intersect to form a right angle, then they are perpendicular. So the converse would be switching the hypothesis and conclusion, which would mean if 2 lines are perpendicular, that's the symbol for perpendicular, then they intersect to form a right angle. So again, the converse is switching the hypothesis and conclusion. And here, It's not written in the if-then form, but we can see the hypothesis says if they intersect. That's the if, which means the then is two lines are perpendicular. Then the two lines are perpendicular. So is the converse true or false? The converse is true. If two lines are perpendicular, then they intersect to form a right angle, which means this statement is a biconditional statement, which means we can say two lines are perpendicular if and only if they intersect to form a right angle. And what that means is either direction implies the other. If you know it forms a right angle, then you know the segments are perpendicular. If they're perpendicular, then you know it forms a right angle. So we're going to rewrite this using that biconditional form. So I'm going to write two lines are perpendicular if and only if they intersect to form a right angle. So biconditional means both the original statement and its converse are true, so it's a two-way statement, if and only if. All right, let's go ahead and wrap up this video. All right, 2.1 had a lot of vocabulary, so thank you for bearing with me. Our goals were that we could identify conditional statements, write them, and understand their relationships, that we could identify if a conditional statement was true or false, and that we could write and verify biconditional statements. And we had examples on all of those different topics. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.